Hey everybody, let's zoom out a little bit so we can see the whole paper. We're going to get started on 7.3.1, and I'm sort of kicking myself. I like to use different names for the heading, right? And in this case, I'm using this guy named Lauren Barker. He was one of he was my second principal I taught under. First one here at Windsor Middle School, and he was a great guy. Taught me a lot of different things. So good principal, good man, good friend. So anyway, but I'm also noticing that April 15th, that's my mom's birthday. I should have had my mom's name there, huh? Anyway, let's go ahead and do this. I think you will have fun with these. These are these puzzle type magic trick problems that are kind of fun to do. Um, so let's go for it. Let's have fun. Okay. Go ahead and make sure you have a good heading. Should include your first and last name. It should include your teacher's name and which period you had that teacher. Should include the date, and then what are we doing? Right. So we're doing CPM 7.3.1. I also like for my students to include the problem numbers. So let's go ahead and write 7-8. Whoops, 7-86. Yeah, 7-87, 7-88, 7-89, and 7-90. Okay. All right. That first problem, the first set of problems, I should say, there's four of them, is you want to recall the inverse operation or the undo for each other. Write the inverse operation for each situation below. Okay, what is another way of saying it is what's the opposite? What is the opposite of adding 3/4? Well, what's the opposite of adding something? Subtracting something. If your opposite of adding 3/4 is subtracting 3/4. All right. Now, I think that you guys can do these. So that's the only answer I'm going to give you on this one. Okay. You get the opposite of subtracting 1 2/3, the opposite of dividing by 8, and the opposite of multiplying by 12. Okay. Next set of problems. Next. What do we have here? Let's flip this page over and I'll move the book on the other side so we can see them both again. Okay. And this one is a table. Okay. And what we're doing here is we want to figure out what am I doing here? Pick a number, and that's going to be X. Okay. Now they're using these things called algebra tiles, and I'm showing pictures of the algebra tiles to help you with this. And what we're going to do is we're going to pick a number. Okay. And we're going to pick 3 different numbers. Okay. Now I'll pick 3 different numbers, but I don't want you to pick the same ones I picked. Okay. So here I'm going to say, let's pick 3. Here, let's pick 10. And here, let's pick 16. You pick 3 different numbers. Okay. But right now I'm going to say for this situation, that is my number. That's a 3, or that's a 10, or that's a 16. Now, what happens in this picture? It looks like I have my original number, and then I have 3 more. So add 3. What do I have now? If I started with 3 and I added 3, what do I have? 6. If I started with 10 and I added 3, what do I have? 13. If I started with 16 and I added 3, now I have 19. Now, I'm looking at this picture. I got this original X, my number, plus 3 more. Now I have that and 3 more, that and 3 more, that. I have 3 of those, don't I? So it looks like I multiplied by 3. I took my original number, I added 3, then I multiplied by 3. So if this is 6, I'm going to multiply by 3. 3 times 6 is 18. 3 times 13, 39. 3 times 19, 57. Now it looks like I had this, and now I'm missing this last column. So it looks like I subtracted 3. A lot of 3's in this, huh? So what do I have? 18 minus 3, 15. 39 minus 3, 36. 57 minus 3, 54. And now when I look at this picture, I have x, 1, 2, x, 1, 2, x, 1, 2. Now I only have the x. So what did I do here? It looks like I divided by what? Well, 2, 3, and now I only have 1. So I divided by 3. Okay? So what do I have? 15 divided by 3, 5. 36 divided by 3, 12. 54 divided by 3, I'll tell you what that is, 18. And now it looks like I subtracted my original number, and all I'm left with this. So subtract my original number. My original number was 3. 5 minus 3, 2. My original number here was 10. 10 minus, 12 minus 10, 2. My original number here was 16. 18 minus 16, 2. Now, I don't know what numbers you did, but if you did it right, you should end up with a 2 as well. And this is one of those things where you can kind of go play a magic trick on a family member and tell them to pick any number. And then tell them to add 3. And then tell them to multiply by 3 and take that answer and subtract 3 and take whatever answer they have now and divide it by 3. And then say, now think of your original number and subtract your original number from what you have now. What do you get? And no matter what they do, then you can say, I'll bet I figured out what your original number was, because I'll bet you ended up with an answer of 2. And they'll say, whoa, how'd you do that? All right. Pretty fun activity to do. Try it out. Okay. No matter what number you start with for this set, you're going to end up with 2. Now, if you like those a lot, go back. There's other ones that you can do. Okay. There's other ones you can do and have some fun. Okay. Example is here. Okay. This is where they're showing it. Pick any number, add 5, double it, subtract by 4, divide by 2, subtract your original number, and no matter what, you're going to end up with the same number. Okay. Kind of a cool set of tricks you can do here. They're all in this section. This is all about doing magic tricks. Okay. All right. And again, I think I told you before, there's a lot of math and magic and vice versa. All right. 7 dash 8. Now you're going to draw a rectangle, and they want it to be 5 wide and 7 long. And then they want you to take that and make a new rectangle. Okay. But this time, you're going to enlarge it so that the length is 13. How big is the height? Well, here's when we're trying to figure this out, we have to use what's called a proportion. Okay. This is the length, right? This is the length. I'm going to put a capital L for here. This is called the width, and I'm going to put a capital W for here. And the width of the small rectangle compared to the length of the small rectangle is the same as the width of the big rectangle to the length of it. Okay? That's called a proportion. I could also say the small width compared to the big width is equal to the small length compared to the big length. Okay? It's called a proportion. Okay? And they're pretty handy. Okay? So how do I solve my proportion? Well, I write my numbers. 5 is to 7, like, we don't know, this big width is to 13. Well, what is this? Well, do you know how to solve that? You do what's called cross multiply. This is what Mrs. Teichman was teaching you last week. Okay. So if 5 is to 7, like W is to 13, then I can cross multiply and I can get 7 times W equals 5 times 13. And then I have an algebra problem to solve, right? Let's rewrite this up here with a W first. Okay, and I'm going to go ahead and figure out 5 times 13 is 65. So 5 times, or W times 7 equals 65. I want to get rid of that times 7 so I can get the W all by itself down here, right? Remember that isolate the variable? How do I get rid of a times 7? I do the inverse operation or opposite, okay? The opposite, right? Something we were practicing here. What's the opposite of times 7? Divided by 7. But I had an equation. It was in perfect balance. That's what that equal sign means. And I just divided this side by 7. I am out of balance right now unless I do what? Get my bracelet out. Do the same thing to the other side. Always. If you do something to one side, you got to do the same thing to the other. So now these two things, the times 7 and divided by 7, will cancel each other out, right? And all that's left on this side is 65 divided by 7, and that's going to be my answer for how wide that is. Okay? So go ahead and divide 7 into 65, and I'm going to tell you right now, you want to not make a decimal. When you get a remainder, make this a mixed number by having the remainder go on top, okay? All right, I'm going to let you finish that and see if you can answer those two questions. Next question we have is we have 5 sandwiches and 3 people. Oh, that sounds so much better than 3 sandwiches and 5 people, all right? At least for some hungry guy like me, okay? How much does each person get? Well, you got these 5 sandwiches. You got 3 people. So person A gets this one, person B gets this one, person C gets this one. These ones, what are we going to do? Well, let's cut it in thirds. A gets this piece and this piece, B gets this piece and this piece, C gets this piece and this piece. So that is how much? 2/3, 2/3, 2/3. So each person gets 1 2/3 pieces. Now, check this out. 5 sandwiches, 3 people, 5/3 is the same as what? Some people are like, whoa, how did that work? Well, fraction problems are division problems. Okay, 1 2/3 is how much? All right, perimeter and area. Perimeter of a parallelogram is how far is it all the way around the outside? Perimeter of anything is the distance around. Okay, so how far is it around that parallelogram? It's 14 plus 22. Now, did I go all the way around if I did that? No, you have to do another 14 and another 22. Okay, now some people do a shortcut, do 14 times plus, sorry, that's not 22, 20.2. And then just times it by 2 because that's halfway around. Okay, but you're going to get that. I trust you. Now, how do I get the area of a parallelogram? Well, here for the area, I don't care about that 14. Remember, the area of a parallelogram is how wide is it times how tall is it. So all you're going to do here is go 12 times 20.2. And what do? You pretend there's no decimal, do 12 times 202, and then move your decimal back. Okay? So I'm going to let you guys figure out that perimeter and that area. And I'm going to let you guys figure out this perimeter because that's the 6 plus 7 plus 7.5 plus 17.8. Add them all up. Now, I'm not adding that 4, am I? To get the area, I want to remind you, how do I get the area of a trapezoid? Okay, I know that I worry about this right angles, right? But since this is parallel to this is a right angle too. What do I do? Do I do the bottom times the height? Well, check this out. If I did the bottom times the height, well, that's kind of like doing this rectangle, right? And this rectangle includes all of this and all of that. So that's too big. Okay. Now, if I did the top times the height, well, that's doing this rectangle. It's not including that triangle or this triangle. That's too small. This is like the Goldilocks version, right? The top times the height is too small. The bottom times the height is too big. I want something in the middle of that, right? What's just right? Well, what's the middle of 7 and 17.8? That's the average. That's the median. And guess what? If I get the average of the top and the bottom and times it by the height, that's how you get the area. So what are you going to do? 7 plus 17.8 divided by 2 times the height. That's the area. Okay. And again, how do I write that? I say it's the top plus the bottom divided by 2 times the height. Okay. All right. I'm going to let you guys try to figure that out. And you'll come back tomorrow and check your answers. All right. Good luck, everybody.